Good morning, good morning, everyone. My name is Miss KM. Welcome back to my channel. I hope you're all doing fine and great, because I am. So we're still going to continue with stoichiometry, but with another triangle. Remember, the first triangle was about the Avogadro's constant, the big letter N for your number of particles to calculate your particles, your ions, and etc. This is your second triangle, which is this one over here. So basically, if you guys can't see, let me just go up for you guys. That is your triangle, okay? Right. So let's get to it. This small letter M is your mass, okay? It's the mass that is usually measured in grams or kilograms. This big letter M over here is your molar mass. You see, molar sounds like it's big, right? That's why it's a capital letter N. It's your molar mass. And the unit for that is grams per mole or grams per mole to the power of -1. It's the same thing. You can choose which one you want when you're answering a question, okay? And over here, of course, is your small letter N, which is your moles, and that is your unit, okay? These are all the unit I wrote down for you guys, right? So the small letter M is your mass, which is usually measured in grams or kilograms. Your molar mass, which is your capital letter M, it's measured in, or the unit which is measured in, it's grams per mole or grams per mole to the power of -1, right? And your N is your number of moles, right? So I already done this for you guys. Your small letter M is the given mass of a substance. M, okay? Your N, which is your number of moles, is the number of substances. Remember, your moles, a mole is defined as any amount in a given substance, okay? Any amount is defined as any amount in a given substance, okay? And your capital letter M is your molar mass. It measures the mass of a single molecule, what I just wrote down for you here, right? So let's get to an exercise so that you don't get confused, all right? This is still stoichiometry. We're calculating mass, molar mass, or even number of moles. But over here, this exercise over here that I've given you guys is to calculate the number of moles, all right? The small n, right? I just have 4 exercises, 4. Okay, let me just draw this triangle over here so that we're okay. Okay, this is this one, this is your number, and this is your molar mass. Okay, remember, this is your grams or kilograms, this is your molar mass, which is your grams per mole, all right? And this is your number of moles, your number of moles. Okay, always start with your given, all right? Let's just write down the given before we attempt the question. All right, let's get to it. It says here, calculate the number of moles in each of the following samples. 21.5 grams of boron. Calculate the number of moles, okay? So to calculate the number of moles of boron, what you do is you write down your given. So let's write down the given. This one, remember, your M is usually in grams or kilograms. So you have 21.5 grams. Your molar mass, which we are now going to calculate. We don't have the small letter n, so we're just going to leave that there. But then we're going to calculate the molar mass. Now, the molar mass goes as follows. This might be confusing for the first time you do it, but then when we're going to continue, then it's going to be okay. Right. So how to do that? You're going to say 1 multiply by your boron. So it's boron. Let me go to the periodic table. By your atomic mass. Your atomic mass is the number at the bottom, right? Let me just show you my periodic table, basically. This is what I'm talking about, your bottom. Okay, your atomic mass, your relative atomic mass is the one at the bottom. So for boron, it's 11, all right? So it's just 11. And it's just going to give you 11 grams per mole. That is your unit. Now, because I also wrote down for you guys this. Remember, your M, which is your triangle, is equal to N multiplied by M. Your number of moles is equal to your mass over your molar mass. And your molar mass is equal to your mass over your number of moles. But because we're going to calculate what? The number of moles, your M, your mass over your molar mass. All right. KO. So always write down your general formula, which is going to be your N is equal to M over M, right? Okay, this is it. This is your general formula, okay? And now we have to calculate. So it's going to be this, right? Your mass, which is in grams, over 11. Okay, which is your atomic mass, all right? Let me get a calculator. Over what? 11 is going to give me. You must round off your answer to 2 decimal places if needed, but I always do, so it's going to be. And what is the unit for your N? Let me just do this for you guys. It's moles, all right? This is your unit. And that is your answer. Finishing clear. Now, guys, I'm sure you're wondering, Karen, like, Miss KM, why is it 11 here? Because, remember, your atomic mass, right? The atomic mass of boron is 11. But this is where it gets tricky. If they say 21.5 grams of boron like this, right? If they say, for example, right, your little subscript, okay, this is called a subscript, okay? Let me just do this properly for you guys. If they say calculate 21.5 grams of boron, right? Boron, like this. Okay, let's not give it any element of the periodic table. If they say calculate like this, right? This already is your boron, okay? I know it's getting a bit confusing. Okay, let me just give you something else. Let's say calcium. Now, if they say this, for example, they don't say any element of the periodic table, just give you this, right? You're going to say for your molar mass, right? Your molar mass, what you do is that you're going to say your subscript multiply by your atomic mass. And over here, my atomic mass for calcium is 40, okay? The one at the bottom. And you write down 40 over here. And your molar mass is going to be 80 grams per mole. Or to the power of -1, either way you choose between the two, all right? Okay. But since like there's nothing, and remember, anything like a letter or a number, okay, a variable on its own, it means an invisible one in mathematics. Remember, like, for example, x, right? This is an invisible one. You see, that's why I say 1 multiplied by 11. But if you have a subscript like this, for example, you always take your subscript, multiply by your atomic mass. All right? So don't get confused between the two. Please don't get confused. This is your answer. Let's go over to the next question. Over here, number 2. You're given. Always you're given. All right? Calculate number of moles in each of the following samples. 54.6 grams of manganese. All right. So we're given grams. So it's 54.6 grams. Number of moles we are looking for. Just go like this. And your molar mass, that's what we are going to calculate. Manganese. So we're going to say 1. Because remember, guys, we don't have a subscript. Our subscript is only invisible 1. All right. So that's how I wrote 1. 1 multiply, you don't have to put brackets. On my periodic table, manganese 55, you just put 55 here, and it's equal to 55 grams per mole. Now we found our molar mass, okay? So calculate number of moles. Do this for you guys over here. N is equal to over All right. What is our mass? 54.6 over what? Our molar mass 55. All right, so let's do that. 54.6 over 5, which I'm typing on my calculator. 0.99 moles. Let me just do this again. Sorry, my bad. Moles. Okay, let's attempt those 2 more questions. If you guys want to do it, go ahead, be my guest. So it says here, let's write down our given for number 3, our given for number 3. Hold on. All right, let's write down our given. So this is number 3's answer now. Our given, okay? Of course, we're gonna calculate the number of moles. For what? Mercury, all right? 100.3 grams of mercury. 100.3 grams, okay, of mercury. Let me just do this because the question's at the back of the page. And then your molar mass, which we are going to calculate like right now. Right, our subscript is invisible 1, right? If it was a 2, you would say 2 multiplied by your atomic mass. So let's get to it. We have 1 multiplied by Hg. Where's our mercury now? Our mercury is 201, so it's going to be 201 equals to, so 1 grams per mole. Now guys, because it's an invisible 1, you don't actually have to write down 1 multiplied by 201. You can actually just write down 201 because any number multiplied by 1, it's equal to itself already. Okay, right. So N is equal to mass over molar mass, 100.3 over what? Molar mass 201. Okay, let's see over here. Over 201. It's going to give me, because I'm rounding it off to 2 decimal places, it gives me 0.50 moles. But if your calculator, I press shift and number 6, okay, shift mode setup, number 6, which is fix, and then I click on number 2. Okay, if you guys don't understand what I'm saying, let me just do this. You see over here, if you want to calculate like your how to round off, you press shift. All right, mode setup, number 6, you press number 6 on your calculator. If you want to round it off to 2 decimal places, you round it off to 2 decimal places, your answer. And that's how I got this. Okay, but if you want to remain with your answer, which is 0.49, but remember you're running up to 2 decimal places, so you're gonna of course have to add a +1. That's why if you want to leave it 0.49, you can leave it so. Right, the last question. Let's write down our given. Right. So it says here 50 grams of barium. Okay, 50 grams of barium. Right, number of moles which we are trying to calculate. 50 grams of barium. Let me just put barium, and then our molar mass, which you're going to calculate. I'm adding 1, which is your invisible subscript here, so that you guys can understand where I'm coming from. If it's a 3 here, for example, if this is a 3 here, right? For example, you're going to say 3 multiplied by your relative atomic mass of barium. Let me just look for it now. 137. You say 3 multiplied by 137. But because it's an invisible 1, it's just that. So it's going to be 1 multiplied by 137 is equal to 137, of course, grams to the power of this one. Or you can say -1. It's the same thing. Right. So is equal to over m 50 over 137 right? It's gonna give me 0.36. I'm running off to the to two decimal places. Okay, moles, and that is your unit. All right. So let me just round off and conclude that m is your given mass of a substance. Okay, it's defined as any amount of that substance. Your letter n, which is your number of moles, is your number of substances. Your capital letter N, M, is your molar mass, which is measured in grams per mole, and it measures the mass of a single molecule. Your M, which is your mass, your small letter m, is grams or kg. Your molar mass is grams per mole, all right? And your N is your number of moles, all right? Thank you all for watching my video. I hope you really enjoyed it and gained an understanding and not confusion. Don't forget to like, subscribe, and hit that notification bell for any more videos that I make that pops up. Thank you and bye.